So Walker, why weather? What is it that has drawn you to weather?
Well, I'm a kid of the 80s, and the thing that grew out of the 80s was the Weather Channel. And that's when they used to do a lot of weather on the Weather Channel back in the day. And I've always had a fascination. I grew up in Georgia, and there was a lot of trees, so I didn't get a great view of the sky that frequently, but we had our fair share of severe thunderstorms. And I was always fascinated drawing pictures of clouds. In fact, I have two pictures in my office at Northern Illinois University of that I uncovered when I was cleaning out my mother's house of a tornado before it hit the city and after the city. As you can imagine, these are sort of little drawings that a 7, 8 year old might make. And uniquely, a lot of my research has looked at how tornadoes affect society and cities, and how cities are growing and how those are leading to bigger and bigger impacts. But as far as I can remember sitting on my grandmother's porch and just loving those summer thunderstorms and just the memories. They come flooding back when I think of lightning shows that we would sometimes get at night. And I also remember going to my father's farm, and it was a tin roof. And so when it rained, it was just this white noise. Everybody's got white noise machines now. That was an unbelievable white noise machine. And so I just have very fond memories of the early 80s, and a fascination with weather that grew into a career where my professional career is effectively my love and hobby. And it just doesn't get much better than that. So I'm thrilled with the ability to study what I'm fascinated by on a daily basis.
Yeah, that's just so cool. I think a lot of people are going to relate to that story of just like it's like it honestly for a lot of people it's this obsession that just starts as a kid and it just like you got to do something with it. And I decided to chase tornadoes and film them. So, we all find our own outlets. And Walker, of course, you're a storm chaser. Talk about your favorite there's hundreds, I'm sure, but talk about your favorite storm chase ever.
Oh man. Whew. I can tell you that I'm honestly very bad with dates. I'm a spatial guy, so I can tell you exactly the road that I was on 2 decades ago, but I can't tell you what the date, what year it was, or the date. Um, Probably that Dodge City series of tornadoes. That was a solo chase, and maybe you know the year. I mean, it wasn't that long ago. That was the anticipation of that day. You knew something was going to happen with that outflow and the strong easterlies. Um, and it being a solo chase, it had some qualities and it just kept going and going and going, and that was quite remarkable. But at the same time, being a solo chase was great, but I also missed sharing it with others, even though there were thousands of other storm chasers probably here at the time. There is something about being around people, in your car, and you can celebrate the achievement of seeing what is Mother Nature's most violent wind. And not to say that there aren't extreme impacts to people on the west side of Dodge and other people, the farmers nearby, but there is something mesmerizing about seeing that take place. And it's almost an out of body experience. But that certainly ranks up there. But everybody has their favorite event, and a lot of them are tornadoes. But some of my most, I guess, the ones that I go back to in my lectures when I have a time lapse or something, a lot of these are just slow moving, what I call naked supercells. These supercells that are just sculpted, and I can get out a lawn chair and just watch them. Those are the events that I dream of on an annual basis. So I'm less enamored by the hectic nature of tornadoes and far more interested in these naked supercells. I don't know what that says about me, but I just love slow moving naked supercells.
I believe, Walker, that makes you a structure hipster.
Yeah, we get a negative sort of a. It's funny how some people like, what I call the vapor chasers. The vapor chasers, make fun of us structure people, but I've been very close to tornado, and I enjoy that aspect too, when safety is there and you got your outlets. Um, but I guess I'm getting old. I don't know. I've always been enamored by the structure, and to me, I know tornado dynamics are fascinating, and there's a lot that we don't know and understand in terms of their formation and sustenance. But supercells we understand relatively well, and to me, that makes it's less of a puzzle in my head, and I can actually sit there and say, okay, I know exactly what's going on here. And so I think it makes it more a much more definable event. Sometimes I'm with tornadoes, I'm scratching my head like, what in the hell just happened? And, you'll just think, or why did it not happen?
Yeah.
And it leads to more frustration than happiness.
Yeah.
And a naked supercell out there just slowly rotating around, just that leads to happiness in my mind.
Yeah, I will say you can do both. I love both. I love being close to tornadoes, but when I get those slow moving, as you call them, naked supercells, it's a good day. It's a good
Yeah.
day every time. I just love it. So, Walker, we could talk storm chasing all day long, but the actual reality of this conversation is there's a lot of folks out there who are speaking very confidently about where Tornado Alley is, where it's going, etc. I couldn't think of a bigger expert on the subject than literally the guy who's writing the scientific papers about this very thing. So, just a broad level overview. What's going on with Tornado Alley? Is it shifting, expanding? What's going on?
Well, I always, when I lecture on this, I always state that there is, and I know that it's common, right? It's in our vocabulary, but there is no such thing as an alley. I liken it to, you don't drive down I-35 and cross into North Texas and suddenly it says "Welcome to Tornado Alley," right? And get your T-shirt right here. In this, but when you look at the frequency of these, there are active corridors, and thus an alley. And so the Great Plains is famous worldwide, and certainly in our movies, for tornadoes. Um, and so I'll set that. If we just look at frequency, yes, the central part of the United States, the plains, has more tornadoes than anywhere in the world. That said, if we actually look at what impacts society, which is the footprint of the tornado, so its length times its width, um, shockingly, I think if we look historically, actually the Mid-South has more tornado footprints than the Great Plains of the United States. So if you're just looking frequency, yeah, it makes sense. But in terms of the effect that it has on society, Tornado Alley is actually the Mid-South. If we really want to get down to the numbers. So when you talk about the shifting of this, it's actually some research done by my colleague here at Northern Illinois University, Dr. Gensini, and Harold Brooks, of course, the National Severe Storms Laboratory, who have found over the last 2 to 3 decades that there has been a shift in not only tornado frequency to the east, but also sort of a correlate to that and expected is the environments. The favorable environments for tornadoes have also shifted east. Some might say that, well, if it's reports, it's just a bias. We're more people in the east now, more documentation. I do think that that's a part of it, but overall there is a a shift in the environments eastward as well, which gives me some pause to say it's not just a bias in the reports, it's actually an environmental shift that's occurring. Now, the research over the last 2, 3 decades has shown that shift. And I want to make sure that this is not sort of a in mass, like thousands of tornadoes are suddenly moving over there. It's a very subtle but notable and significantly different shift over to the east in the reports and the environments. But we don't at least looking historically, we don't know if that's necessarily sort of a variability in the climate system or if it is actually being induced by climate change. What I can tell you that the latest work that we've done is we've projected this out into the future. And so we're not only looking at environments into the future, but we're actually looking at what we consider synthetics reports or just supercell events themselves. And we are seeing the same eastward shift.
Yeah.
So that makes me think that as we go through the 21st century, that we're really starting to see climate changes effects, anthropogenic climate changes effects on these trends. Not to say that there can't be other variables like more El Ninos or La Ninas or whatever it might be on this trend, but overall, I'm confident in saying that the trend that we've seen the last 2 to 3 decades is going to continue into the 21st century.
Yeah, on in your paper, actually, I was reading the one on supercell frequency. You talked about really that you offered that with Gensini and a couple other people. I'm sorry, I'm forgetting their
Alex Haberly
yeah.
and Victor Gensini, yeah.
Yeah, and y'all talked about how basically it looks like there's a couple of things happening. First off, you have the space, where they're happening, but also when supercells are more likely to happen. You're talking about less in the summer, more like in the cool season. Could you talk about that a little bit?
Yeah, so to pull back, what we did is we don't just take global climate models. Of course, global climate models are run all the time and they produce massive amounts of data, but they're at very coarse resolution. So they're at anywhere from 50 to 200 kilometers grid scale resolution. Now, your listeners certainly know that that's a supercell is much smaller than that grid scale resolution. So what we do is we take this GCM data in some form or fashion, we feed it into a weather model. This is WRF, which is frequently used by storm chasers. And we run these simulations at 3.75 kilometers. So we can resolve things like supercells. We can even resolve the updraft helicity, the rotation within these storms. And so what we do is we look at two different things. We look at the variable, the sort of what we call the implicit, which is the environmental changes. So how is supercell composite parameter, which is this nice little silver bullet sort of thing that mixes instability and shear, how is that changing over time? And guess what? We're seeing a kind of a shift eastward with a decline in the Great Plains. But we can actually simulate reflectivity and updraft helicity, these variables that storm chasers look at all the time, right? To forecast where they're going to chase. We can simulate these in these models. And we can track the supercells. And then we basically compile all those data. And we do it historically, so we can kind of get some confirmation that we have confidence in our simulations. But then we also project under warming scenarios out into the 21st century. And this is that explicit part of the modeling. We're actually simulating the actual storms, which our global climate models do not do. And we track these, and guess what? We're seeing greater populations of supercells to the east and a declining supercell population in the Great Plains of the United States. Temporally, over the season, what we're very significant increase in sort of that February, March timeframe. So one might just say an earlier season start. I would think that would be more outbreak days in February and March, where traditionally we've had more of an April and May. That's going to shift earlier. May uniquely in the historical and in the future simulations is about the same. So if you're storm chasing in the future, if you're going to make it through the 21st century, which I probably won't make it all the way through, but hopefully I'll make it a long way into the 21st century. You're still going to be able to chase in May and get the similar sort of ingredients. We don't see a major drop off in May, but once we get into June, and certainly as we get into July, the number of supercells rapidly declines in our future simulations. So as a sucker for June, that's somewhat
Don't tell
depressing.
me that. Don't tell me that. I
Yeah,
love
yeah. I like,
June.
again, these slow movers and these naked supercells, which are a June sort of phenomenon typically, are going to more than likely wane quicker as we move into the 21st century. And I also think spatially they're going to shift further north. So we'll see more of a northern plains into southern Canada stretching down into the Midwest and Ohio Valley. So that corridor there might uptick, but the plains themselves are going to, traditional sort of chasing territory is probably going to see a decline as we move into the 21st century.
Yeah, and you're talking about that, and honestly, the thing I'm thinking about is just the last decade and on the southern plains, it's just like where where'd the supercells go in June? Like it's just
Yeah.
like, yeah, my first, it's so different. I don't, I think, I think we're both, I think you would agree that you don't know if that's part of this trend or just a weird 10-year blip, but might be a preview of what it might be like.
Yeah, you talk to the old timers and the Al Mullers and Chuck Doswells and whatnot, and all their favorite chases are in the Panhandle of Texas, right? And we do have some tornadoes and supercells in the Panhandle of Texas, but they made it sound like in the 80s, 70s, 80s, and even 90s that it was just like you would just drive out there and see it, like they were cows, right? Like they were cattle out there. I think that there has been a notable decline, and the research is certainly suggesting that this is not only historically the case, but it's going to actually increase or amplify into the future. And it's, in terms of a theoretical exercise, it's not that complicated to understand. What's happening is the desert Southwest, the Mexican highlands are heating up and drying out. That creates a very, very nice mixed layer, a hot mixed layer, hot and dry mixed layer. So while the mixed layer has always been hot and dry, it's getting hotter and drier. And of course, when this advects over the Great Plains with a shortwave trough that's moving in or just westerly flow, that means, and you know all too well, a more stout capping inversion. And so when we talk about West Texas and Central Texas, Western Oklahoma, Western Kansas, and Colorado and New Mexico, you're going to be dealing with a more stout cap overall, collectively wholesale. And that means suppression of storms, unless you can get a good upslope flow and get initiation off the Sangre de Cristos or the Palmer Divide or whatever it might be, which is still going to occur. But you're less likely to sustain those out into the plains and more than likely not to get initiation out into the plains, even on a formidable dry line circulation. So this all logically makes sense with even the global climate models and what our projections are. It makes sense that we would see a decline in sort of isolated supercells that we all sort of are fascinated by.
Yeah, something you're talking about there too. I mean, we also know that if when the planet is warmer, the jet stream is weaker. You talk about how, we have more cape, more and less shear. I mean, we see it every single year. The shear goes away in the summer because it's warmer in the northern hemisphere. I mean, this isn't a secret. This isn't something we don't know happens. I mean, it happens every single year, right?
Yeah, and it's effectively what we call the thermal wind. I always start a lecture on, even if it's a elementary school lecture, right? I talk about what are the fundamental reasons why we have weather on this planet. Well, we're on an oblate spheroid, we're tilted, right, and that leads to excess heat receipt at the equator and a net loss at the poles. That creates a thermal gradient between the equator and the pole that sets up this thermal wind, which in both hemispheres is actually westerly. We live in the mid latitudes, we get to see the full effect of that. And as you mentioned, in a climate change scenario, a very scary climate change scenario that we're living in right now, is that the North Pole is effectively going to become water within our lifetimes, during the warm season. And that leads to a weakening equator to pole temperature gradient. And thus, density and pressure and all these other variables that go along with that are going to weaken as well. And the result is a weakening wind, a jet stream. Now, there is some research by Jeff Trapp, Michael Tippett, and others that looked at these global climate models and looked at that specific phenomenon, the decreasing winds in the jet stream, and it's there as we go out in the 21st century. But what they found, sort of oddly, is that that decrease is on days when we don't have a lot of CAPE or instability to begin with. And so on days when we have sufficient CAPE and instability in the environment, the wind shear is actually still there. So all else being equal, if you know the four fundamental ingredients we talk about with severe storms are moisture, which is going to increase in the future under a climate change. That's a simple physics exercise. Instability, of course, is naturally going to increase. When we talk about the generation of instability, we need boundary layer moisture. All right. Wind shear, which we thought was going to decline, it is overall, but unfortunately it's level on days when we actually have instability in the environment. The big wild card to me is the lift. How is our forcing going to change in the future? And global climate models don't get that. And that's why we simulate at this very small scale to actually force the storms. And we can look at the changes in lift. And what you're seeing is even though there might be dry line circulations and upslope and so on and so forth, just deep mixing, you just don't get as much initiation out in the plains, the high plains in particular, as you do off to the east, along the fringes of that elevated mix layer, as you would expect. So I don't think any of this is sort of would be unexpected, but there are some unique little flies in the ointment, some things that you think would occur, but sometimes it doesn't work that way on a day-to-day basis.
Yeah, it makes so much sense. You know, we're talking about, you know, as a storm chaser, I'm hearing this and I'm going, well, I guess I'm gonna get my Christmas money and we're gonna spend for cameras, and then like 30 days later we're storm chasing. I mean, are we gonna be storm chasing a lot more in February and March? Is that how this is going?
Well, there's a lot more people just doing that anyway. So it's not for me. You know, it's not for. I grew up chasing in North Georgia, which is really just driving around looking for condensation with trees staring you at the face. And it's just not for me. But clearly there is a lot of, at least some of my students, right? I mean, there's a lot of people that drive, you know, hundreds if not 1,000 miles to go chase in the South. Do I think that that is going to be a more fruitful opportunity in the future? Yes. The research suggests that, you know, Alabama, Mississippi, Louisiana, Arkansas, Missouri, Southern Illinois, Tennessee are going to see a significant increase in severe storm environments and, you know, hail reports as well as tornado reports. Damaging winds is a complex subject. I'm not going to get into that, but you know, the perils that supercells are typically aligned with, hail and tornadoes, we're going to see increases in there. So, you know, yeah, if you're up for dealing with some trees and some curvy roads and some terrain that is less than pleasurable for me in terms of I like to be able to see the sky. Yeah, I do think that the trend is your friend down there.
Yeah, you know, it makes a lot of sense to me too, what you're talking about. Something that I noticed in the paper was, first off, that made it and seemed to change much, but also that April seemed to be, it seemed like June's losses were offset by April's gains. And there's plenty of research out there showing that, you know, warmer Gulf of Mexico temperatures in April just lead to you know, big things in April. Is that something that we can look forward to? Is there going to be like a bigger April to look forward to for storm chasers?
Yes, I think that March and April, I think stretching into February too. February, March, and April are really going to see a notable uptick. Now, February, March have relatively low numbers compared to April and May, so you might get your biggest bang for the buck just if you do a 10 or 20% increase in April. Well, your numbers are going to be bigger in April than a 10 to 20% change in February. It's just climatology. So, for our eyeballs and for our brains that can wrap our heads around sort of climatology, yeah, April is going to be, and we've already had that, right? I mean, April 27th, we've had some April. April is notorious for its big outbreaks across sort of the east of Mississippi, south of the Ohio Valley. Um, and so I would expect that is in just this year, right? I mean, you
Hmm.
can look at this year and now, I don't want to say that this is the fingerprint of climate change, right? We're dealing with a La Nina. It's complex. But overall, this sort of parade of cyclones, and as they come along, of course, a nice magnet. They pull that moisture that is, abnormally high sea surface temperatures in the Western Caribbean and the Gulf of Mexico. You got your source of moisture. It might as well be a boiling pot of water just sitting there waiting. And even just subtle intrusions of this, even if our lows are across the Gulf, you get tornadoes in Houston, which is really quite unusual outside of a tropical cyclone. So New Orleans, right, hit twice in the last year. I mean, those are some interesting events that aren't that common, and yet we're seeing them more frequently.
So, Walker, I think what we're talking about here, what could be the case, you're talking about a possibly stronger cap, maybe especially so some years more than others. You're talking about more instability, more moisture, those sorts of things. It sounds like that cap's going to come into play. And it sounds like we may have some years where that cap's just so strong, nothing happens. And we have some years where that cap is just like just right, where we just go bonkers, which isn't so different from today. Am I right about that? More.
That's right. I mean, I think whenever we talk about climate change, a lot of folks, whether it be just temperature or whatever phenomena that we're talking about within the climate system, we look at the change. A lot of people just talk about the trend in the line. As is it going up? Is it going down? Is it staying flat? Actually, one of the biggest fingerprints of climate change on almost any peril is its variability. For the statistical among us, it might be the standard deviation, the variation around the mean. And what we see is that pretty much across the board is that there's going to be increased variability. So as you mentioned, this boom or bust that we tend to think of on an annual basis anyway, right? At least on a 2 to 3 week sort of, oh, it's quiet, oh, it's active. It's what we're going to see is probably more of that. So some more very, very quiet periods, but also on the flip side, some more extreme events when they do occur. And this is not unlike some of the work that would be suggestive of Dr. Brooks that has looked at sort of this clustering of tornadoes, so that when tornadoes do occur, they tend to be more of them and clustering of them. That's to me kind of what we're seeing across the board with these severe weather perils, but also other perils. Yeah, heat waves, cold air outbreaks, so whatever it might be. The increased variability seems to be a hallmark of climate change. Um, and so for storm chasers, that means that you're going to have some more probably crappy years. And certainly if you pick your 2 week vacation period wrong, you're going to be sort of going to look at the national parks out west. Rather than seeing any sort of condensation. But on the other years, if especially if you happen to time it right, it's going to be extremely active. And I expect that sort of trend of greater variability to increase into the 21st century.
So what you're talking about, it sounds like, especially, I mean, for everybody, storm chasers, people alike, is that it sounds like we're going to have more years like 2016 or a 2013, where it's like nothing, nothing, nothing. Oh my gosh, what happened? We've got 2 weeks of nonstop stuff, and then nothing, nothing. It sounds like that's kind of what you're talking about, right?
Yeah, and I'm talking, sort of macro scale, almost decadal, right, of these trends. Whereas on a week to week basis, there's lots of other factors, right? The El
Yeah.
Nino, La Nina, MJO, whether we even just have a split jet stream or not, it can really dictate a season. So But just writ large, variability is going to increase in the future. So we can't just say, oh, look at the rapid increase in the number of tornadoes off to the east. Well, it's probably not going to be this nice straight incline. It's going to be have a lot of variability about that line. And that's, to me, what's so interesting about that is society might not be as well prepared for that variability. Like if we know consistently that we're going to get something, in April or May, we can sort of prepare for it. But let's say it goes quiet for 2 or 3 years, we kind of lose our sort of guard. And that's what and I don't want to call it complacency, because there's actually a lot of great social science research being done on complacency. And some of it is finding that it's not necessarily a real commonplace feature as we once thought. But I do fear that society as a whole will not be as prepared as we move in the future just because of the variability.
Yeah, and we're talking, you mentioned society. There's so many facets to this about how we're talking about where we're going in the future. First off, we're talking about perhaps a increase in frequency of tornadoes where there aren't as many basements, where there's more mobile homes, where there's more, just simple point, there's towns every 10 miles versus every 30 miles. Like, seems like a big deal to me.
Yeah, I mean, this is some research that I did, goodness gracious, going back to 07, 08, really trying to figure out, and I just used a simple marker. The ultimate sort of impact for a tornado is death. Um, and so I used mortality as this marker. And what I found is, of course, the Mid-South, and this is before April 27, 2011, and then Joplin and so on and so forth. The Mid-South has by far and away greater mortality than the Central Plains of the United States. As we were talking about Tornado Alley and frequencies earlier, just based on frequency alone, you would think there would be more death in the Great Plains. And in fact, there's actually far less death out there compared to what the climatology suggests. And what it comes to is just this intersection. A lot of times, storm chasers or meteorologists or climatologists, we think of the physical science. That is, how does the risk change? How is the tornado climatology shifting? How is the environment shifting? But what creates a disaster is the intersection of a hazard, a peril, with society and societal vulnerabilities in particular. And you mentioned some big prominent variables, right? Mobile homes, lack of basements, population density. All of these are under the hood of what we would consider societal vulnerability. And what we found is in the Mid-South if you just look at all these variables that create vulnerability, the Mid-South is off the charts on them. It just has a very high vulnerability, whereas the Great Plains has a far less vulnerability. Now, there is vulnerability there, don't get me wrong, right? We've still seen death and injury there, but it's far less than what you see in places like Alabama, Mississippi, Arkansas, Louisiana. And so, as we talked earlier, we talked about the shifting of the risk, but at the same time, we have this increased vulnerability under the landscape, really under the hood, if you will. And you commingle that with the increasing risk, it just portends, you're going to have more and more disasters as we move into the 21st century. So these sort of big outbreaks that are very impactful, we thought these would be once in a generation type events. I don't think anybody wants to see another April 27th, but I would say that the odds of something like that occurring again are actually increasing, not just because of the change in the risk, but because of the increasing vulnerability of society.
Yeah, and another thing I know your paper on supercell frequency touched on was actually time of day, and you talked about how there'd be more threats even at night, which we all know is like that's a thing, that's a problem for folks. So could you talk a little bit about like what y'all found there?
Yeah, I mean, overall, if you look at the Eastern continental United States, we didn't see a lot of change on the diurnal cycle. But when we looked at specific regions, two really came up, the Mid-South and the Northern Plains. The Mid-South saw this really uh, abrupt shift towards evening and overnight. So we know that this is a region that already gets a lot of overnight and evening tornadoes, and even early morning tornadoes. What we saw is that's going to actually increase in the future, which is of course very problematic from a warning standpoint, from a societal impact standpoint. People are at their most vulnerable during the overnight hours because first and foremost, they're usually in housing stock. And upwards of 70% of deaths occur in housing stock. So you're in a much weaker home than you are in a place of work during the daytime or school or wherever it might be. Of course, getting and receiving warning information at night. I don't know how well you sleep, but a lot of people sleep pretty well. And they mute their phones and they turn off the alerts. They don't have a weather radio, and even let's just say at 3 a.m. you do the wireless alert goes off, right? And you're in a mobile home in rural Alabama. Where do you go? So these are, I hate projecting death and injury. I don't want to do that, right? That's kind of the opposite of what I'm trying to do. But we need to be prepared for it, whether it be the emergency managers, the National Weather Service, research into these specific issues, which of course perils is ongoing down in the South where they're studying these particular events. And there's lots of great social science research trying to understand the human brain and how it factors into a lot of these features. But I I hate to be a forecaster of bad omen, but I see worse and worse disasters into the future, at least in terms of human impact and their costs. The good thing is that overall tornadoes are killing less people than they were in the 20th century, but our numbers have bottomed and are actually increasing in the last couple of decades. In terms of monetary loss, it's going to rapidly increase as we go into the future. So I hate to be the bearer of bad news. For those in the northern plains, we see the exact opposite. We see sort of less vulnerability, but also sort of a shifting of a risk towards more of a daytime event. And that might be good because we get more sculpted supercells during the day, but kind of the exact opposite of what's happening in the Mid-South.
I am going to work on my love of maple syrup and my ability to convince border guards that I need to get through pronto for this tornado. That's what it sounds like to me.
Yeah.
So on another note, this is kind of, but not really related. It sounds like we're talking about less supercells in the summer and perhaps even less storms in the summer across parts of like the Southern Plains, which historically on the Southern Plains, June is the rainiest or the second rainiest month of the year. That's when you're talking about places like Amarillo or Lubbock, Clovis, these places on the high plains. It seems like a pretty big deal on just a non-storm impact, a very basic impact of just like water, like water management.
Yeah, water resources out in the high plains and certainly the desert Southwest are going to, I mean, we're seeing it now. It's already an issue. In a lot of our cities, I mean, Lubbock and Amarillo have grown, right? And I'm not even going to talk to the agricultural use of these resources. It's significant. Um, I worry about the high plains towns that we love to visit and that we stay in frequently, right? From Shamrock to Garden City to Goodland. What is to become of a lot of these centers out there, and more importantly, the very small towns that are around them, as we go into an environment that is not going to be supportive, at least in terms of one of the most fundamental life variables there is, and that's water. Um, we look at the recharging of the Ogallala Aquifer in particular. It does recharge in Nebraska, but we've seen significant declines in Kansas, Oklahoma, and down into the Texas Panhandle. And that's not one of those things that you could just recharge in a year and call it a day, right? It suggests some significant fundamental problems with these population centers out there and the overall sustainability of agriculture. And I don't have an answer for you on that. I just, as a person who loves these areas and loves to visit them, I'm scared for their sustainability.
Yeah, absolutely. So, Walker, it's time for you to sound extremely smart because we all know the smartest people uh, are aware that they don't know everything.
The
Uh,
old Dunning-Kruger effect.
yeah, you are aware of that. So, what don't we know? What are we looking? Where are we wanting to go to learn more in the future in terms of the science of like the future of tornadoes, the future of convective storms, supercells, etc.
Well, we can always learn across the board. As I go to some of these conferences, I'm always, I can think of the Hell workshop we had at National Center for Atmospheric Research last fall, and what I came from that workshop was, wow, we don't know much. Here are all the smartest people studying hell. They all meet in Boulder or virtually in Boulder, and my conclusion was we don't know much. And so, in terms of my own research, these simulations that we've done are just at the beginning stages, right? We've only just had the computing capacity from the National Science Foundation and others to generate these sorts of simulations. We've done global climate models for several decades now, but these very high resolution models that can resolve the actual thunderstorms themselves are just, they're babies. And so what I hope is in 2 to 3 decades, I will laugh at the amount of data that I had, right? Even though it's roughly 700 terabytes of data, I will laugh and say, wow, that was a joke back then. We are now running 20 or 30 or 40 or 50 ensembles of these. And we will have petabytes of data that we can process with machine learning and AI to get the answers that we need really quickly, because we are in this grand experiment of climate change and societal change, right? It's just not climate change. Massive, significant changes in society, most importantly, explosion in population and sprawling of that population, which we call the expanding bullseye effect, which leads to, unfortunately, more impacts. On the physical science side, I think we're going to continue to make inroads there, and through modeling and even observations and field programs, understand what is creating these events. I'm more concerned about that social science and really the underfunding of that research over, well, forever. There's a lot more interest in it now, but there needs to be more funds, more sophisticated methods, more people studying it. Like, I know everybody's a weather nerd and just want to learn physical science, blah, blah, blah. But we need people that are good at comms and good at psychology and good at these fundamental things and do qualitative research. Because the most important thing when we talk about societal impacts is our brains. And we are just now scratching the surface of our understanding of how a brain receives information on severe storms and what it does about it, and more importantly, what it does about climate change information. Um, and I think we've all seen over the last 10 years or so, social media and what it can do to information and misinformation. So I'm really interested on both sides of the coin, and I think we need to study them equally. And we'll have a rich future of understanding a lot of these phenomena. But I always state that we are in the experiment. We're not conducting the experiment. We're in the experiment right now.
Yeah, that is so true. Walker, how can people get in touch with you if they're interested in following your storm chasing exploits this next year?
Yeah, I don't post as much on social media anymore. It's tough to, right? It's tough to find the time. I got kids, I try to make time for everything, as well as research and teaching. But they can see me on Twitter. I do a lot of time lapse. Time lapse is my I guess my calming, soothing thing in the off season, processing time lapse imagery. You can see me on Twitter at Walker S. Ashley. My homepage has all of my research, all of my publications are there, and that's Chubasco, .niu.edu. You can just do a search for my name and I should come up at the top of Google. At least I hope so. So if those that are interested can find me.
Awesome. Thanks so much for joining us, Walker.
Thanks for having me.